Physics part 303. The solution for the discharge of a capacitor of capacitance C through a resistor of resistance R is the form Q is equal to Q naught E power raised to minus VCR. This is the equation of the graph in figure. Here Q naught is the charge on the plates at the time 0 and Q is the charge at time t. The graph of the figure at this situation have exactly the same shape, and thus the equation for the discharge of a capacitor may be written as I is equal to IgE minus VCR. Furthermore, since for a capacitor Q is proportional to V, then the solution for discharge can be written accordingly. Time constant. As time progresses, the exponential curve in the figure gets closer and closer to the time axis but never actually meets it. Thus, it is not possible to quote a time for the capacitor to discharge completely. However, the quantity CR is in the decay equation may be used to give an indication of whether the decay is fast or slow. CR is called the time constant of the capacitor resistor circuit. Decay curves for the large and small time constants. Large value of CR and small value of CR. CR has the units of time and is measured in seconds. We can easily show that CR has units of time from C is equal to Q over V and R is equal to 7 VII. Then CR is equal to Q over I. Since charge Q is in coulombs and current I is in amperes, and 1 ampere is equal to the 1 coulomb per second, Q over I is in seconds. To find the charge Q on the capacitor plates after a time t is equal to CR, we substitute the exponential decay equation. Thus, the time constant time for the charge to have decreased to 1 over E is equal, or we can call it 1 over 2.78 of its initial charge. In one time constant, the charge stored by the capacitor drops roughly to 1/3 of its initial value. During the next time constant, it will drop. During the next time constant, it will drop by the same ratio to about 1/9 of the value at the beginning of the decay. We've got an example. Well, we've got a 500 U farad capacitor connected to a 10 V supply and is then discharged through a 100 K omega resistor. Calculate the initial charge stored by the capacitor